So good evening, students. Today in chemistry, the first question that we feel is given from Raoult's law directly. So they are asking for calculation of the total pressure. I think we all know the formula of Raoult's law that tells us that this PT equals to psi A into PA naught plus psi B into PB naught. We all know this formula. Now what we do actually replace this psi B as 1 minus psi A. So as soon as I write it, so it will be psi A PA naught plus 1 minus psi A, because we know this from the formula of mole fraction, 1 minus psi B PB naught. After putting the values, what we are going to get? We are going to get PB naught plus psi A along with PA naught minus PB naught. So option D will be right answer. You can solve it. You are going to get this as your total pressure. So question number 1, we are getting PB naught plus psi A multiplied by PA naught minus PB naught. Now coming for question number 2. If you see, students, they are asking of total number of structural isomers possible. I hope you understand we need not to consider any optical isomers, just the structural formulas or forms will be enough. So let's start C4H8. According to the formula of alkane, alkene and alkyne, we easily can understand that is nothing but alkyne in nature. Now, what kind of alkynes we can expect? First one is CH3, CH2, CH double bond CH2. This is our first. Continuing with CH3, CH double bond CH3. This is our number 2. Number 3rd being something looking like this. Of course, I hope you understand this is nothing but cyclobutane. This cyclobutane will be also number 3rd. Now, why I'm considering cyclobutane? Because if you calculate the formula, it will be C4H8. So I think we know whenever it is a ring structure, cyclo compounds also acts as alkene. Along with it, our next one will be CH3, C double bond, CH2, CH3. So this is also my alkene. Another one, this is number 4. And last one, we can take one more cyclogen, CH, CH, CH. Here, 2 bonds, CH2, 2 bonds, CH2, and one more CH2. So this will be my 5th one. So total, how many I'm getting? 1, 2, 3, 4, 5. So overall, isomers possible for this will be 5. Next question, number 3. If we go for question number 3, they are asking that identify the element for which electronic configuration plus 3 oxidation state is argon 3d5. So as we are going for argon 3d5, we can easily figure out that it will be having electronic configuration of something more than 3d5, because on its 3rd oxidation state we are getting argon 3d5. So the one that is easily coming to our mind is Fe, because the electronic configuration of Fe is argon 4s2 3d6. As soon as you make it Fe3 plus, you will be getting argon 3d5. Next question, question number 4. So in question number 4, what we are observing then among the following species, which one is not having the same type of hybridization as others? If you check carefully, all of them are having one hybridization. What is that hybridization? Whether you're talking of SF4, whether you're talking of I3 minus, everyone, or PCl5, everyone is having one hybridization, that is sp3d. Only the one that is this one, SbCl5 2 minus. In this case, Sb belongs to which group? It belongs to group number 15. From group number 15, if you see, it will be having one lone pair, and as it is 2 minus, there will be 2 coordinate bonds. So Sb will be looking like this, Cl, then one lone pair, then here is one Cl, then is one Cl minus, there is one Cl minus. So it will be what? It will be taking the shape of, or the hybridization of how much? 1, 2, 3, 4, 5. After it takes 5 plus 1, So it is 5 bond pair plus 1 lone pair, giving me sp3d2. I have not drawn the proper shape, just for representation we are seeing. For representation, we can say that it is giving me 5 bond pair and 1 lone pair, overall making it what? sp3d2. So it is not having the same. So answer is sbcl5 2 minus. Now question number 5. For question number 5, we are observing they're asking us that which carbocation is most stable. This is the easiest question I feel, because in this case we know benzene with CH2 plus has better resonance occurring from here, and someone who will be present OCH3, whoever will be present to donate the lone pair, it will be giving us what? It will be giving us more electron density over here, and due to that more electron density, it will be more stable. Henceforth, this one is my most stable carbocation. Followed by the next, if we are facing number 6, which of the complex is not expected to exhibit isomerism? The answer is the D1, that is nickel, NH3, twice Cl2. In this case, there are 4 bonds, but the shape that will be taking will be tetrahedral. Due to the tetrahedral shape of this compound, we will be observing that there is no isomerism. This is an exception we should keep in mind. There will be no isomerism. Now, question number 7. What is question number 7? Question number 7, they are asking that for Lazane's test, nitrogen organic compound. So this is a memorized base question. The compound which will be giving us Prussian blue color is nothing but Fe4, FeCN whole 6, 3. Now this compound will give us Prussian blue color. Going for next, they are asking among the lanthanoids whom have 4F7 configuration. I hope all of you are okay with or good with the remembrance of the electronic configuration. Among this EU2 plus and GD3 plus, these are the ones who have what configuration? They will have 4F7 configuration. Next, question number 9. They are asking us to match the following. First of all, let us start with nickel NiCO whole 4. Students, when I talk of NiCO whole 4, NiCO whole 4 is directly a complex which will become outer orbital due to the presence of 4CO. It will act as outer orbital complex, and that's why it will be giving me sp3. Since nickel does not have any oxidation state 2 plus or something, it can't make it inner orbital complex, so hybridization will be sp3. Coming for the next one, the scenario changes as soon as you give NiCN4 2 minus. This will not be inner orbital complex. This will be outer orbital complex. Sorry, this won't be outer orbital complex. This will be inner orbital complex. Hence, it will give us dsp2. So it is outer orbital complex. This is inner orbital complex. Followed by the next, they have given us CO, again cobalt with cyanide whole 6 3 minus. This one again, cobalt is in +3 oxidation state. Being in +3 oxidation state, it will give inner orbital complex due to pairing, and the configuration will become T2sp3. This is also IOC. Last and the final one, if we look, we are going to get the complex of COF6 3 minus. In this case, students, if we observe, we will see that 6 fluorine and 3 minus. Fluorine is not a very strong ligand to make things pairing. So henceforth, we will get the configuration of sp3d2, which is due to the formation of outer orbital complex. So this is the reason for each of their configuration. Continuing further, we are going for the next one, number 10, which is about a reaction of hydrocarbon. When you react benzene with 3Cl2 in presence of sunlight or H nu, both are same. you do get something called as BHC, benzene hexachloride, where all the double bonds are being replaced by chlorine. This is called as BHC or benzene hexachloride. Some of you we call it as gamaxine as well. Question number 11 discuss is discussing about the incorrect statement. I think we all know sulfur can have oxidation state 0 to +6, but in SO2 sulfur is only having oxidation state of +4. So it can act as reducing agent also, it can act as oxidizing agent also. That is, it can increase its oxidation state as well, it can decrease its oxidation state as well. So it can act as both reducing and oxidizing agent. So henceforth statement number 4 that it does not act as a reducing agent is wrong. Question number 11 done. Question number 12. In question number 12, they are asking that the rate constant of a reaction become equal to the pre-exponential factor when it becomes equals to the pre-exponential factor whenever the absolute temperature is infinity. Whenever the absolute temperature is infinity, we do see that the rate constant of a reaction becoming equal to what? Becoming equal to the pre-exponential factor. Next, question number 13. If we go, we do find that they are asking us about ozonolysis. I hope we all know we have seen this kind of question in previous exams as well. Whenever it comes to ozonolysis, we should write down the carbon containing the oxygen in such a manner that will have arranged in like this. As soon as you arrange this, what we will be getting? We will be getting that the oxygen from both the compounds being eliminated. As soon as it gets eliminated, I will be getting a compound looking like this. Double bond CH2, CH3, CH3. Now, what was the question? The question was the alkene. So this is my alkene, option number A. Question number 13 done. We are moving towards question number 14. In question number 14, what we see, they are asking us which species have sp3 hybridization. When we talk of NF3, there are 3 bond pair, 1 lone pair. As 3 bond pair, 1 lone pair, overall it will be giving me sp3. Same for H2O. How many central atom is oxygen? 2 bond pair plus 2 lone pair. It will also give me what hybridization? sp3. So NF3 and H2O is the correct combination. Next one, if you look question number 15, you will see that they are asking us a reaction which do indicates there is first of all substitution reaction, then there is acidification. That is, if I take CH3CH2, we are reacted with KCN, I will immediately get CH3CH2CN. As soon as you reacted with HCl, you are going to get what? You are going to get CH3, CH2, COOH. That will be my final product, option number 4. The next question is, among the following, who is the best oxidizing agent? Students, when we talk of oxidizing agent, the agent who takes electron from others itself get reduced, that is called as oxidizing agent. When we talk of Mn3 plus, Mn3 plus do have the configuration of 3d4, argon 3d4. I hope you understand it. If it gains one electron, it will immediately become argon 3d5. And just to gain that one electron, this is a very strong oxidizing agent. This acts as a very strong oxidizing agent. Question number 17. In question number 17, we do see that they're asking the largest number of oxidation state are exhibited by actinoids. Then those are by lanthanoids, the main reason being, first of all, it is being shown by actinoid, then the lanthanoids. Why it is being done like this? Because it has been found that lesser the energy difference between 5N and 6D than between 4F and 5D. When we go for 5F and 6D, the difference of energy, let's say if this is 5F and if this is next one is our 6D, so 5F and 6D will have, let's say, X. Similarly, if I talk of our next two orbital, that is 4f and 5d, this will have, let's say, y. So we will always find that the difference of 5f and 6d, x is less than y. And due to this reason, we always see large number of oxidation state exhibited by actinoids, that is this one, rather than lanthanoids, because from actinoids, the easily we can take out electron from both the shell, but for lanthanoids, it is a little bit difficult. That's the reason. Question number 18. Here comes in lanthanoid contraction. One more concept comes in here, that is called as lanthanoid contraction. Due to lanthanoid contraction being more efficient than actinoid contraction, lanthanoid contraction occurs more, and henceforth 4f orbital becomes deeply seated. We use the term deeply seated. And due to being deeply seated, it becomes more far or more difficult to take out electron from 4f. Question number 18. Question number 18 tells us that which one is the best halide to reactive towards SN1 reaction. I hope everyone remembers SN1 is directly proportional to the stability of carbocation. And as it is directly proportional to carbocation stability, we need a carbocation which is very stable, and henceforth CH3, CCH3, CCH3 plus is a very stable carbocation. And henceforth option number 3, that is tert butyl fluoride, shows very good SN1 reaction. Shows very good SN1 reaction. Next, question number 19. In this statement, they are giving two statements in this question. The limiting molar conductivity of KCl strong electrolyte is higher to that of weak electrolyte. Okay. Second one is molar conductivity decrease with decrease in concentration of electrolyte. First of all, let us solve the first equation. The limiting molar conductivity of KCl is higher to that of CaCCOOH. In this case, what we need to focus that the limiting molar conductivity of KCl. Limiting molar conductivity means the conductivity at infinite dilution. If you remember, when you were plotting the graph, KCl was coming like this, whereas this was coming like this, the weak electrolyte. This was KCl, this was CH3COH. At infinite dilution, this was increasing, whereas KCl was having some definite value. So as KCl has a definite value, CHCCOH has infinite value. So the value of limiting molar conductivity of CH3COH will be more than limiting molar conductivity of CH3COOH, right? Wait 1 second. The whole thing is written. Yeah, I hope I'm sharing as well. So yeah, here we are observing that here the delta will be, or the capital lambda of CaCCOH will be more than that of KCl. Is it clear? Now, continuing further, what we can say is, next question, leave it there. Next question, as this is the scenario, so we can say the first statement is false. Now the second statement, what is the formula? Molar conductance equals to kappa into 1000 by molarity. Now if volume increases, concentration decreases, molarity will decrease. If molarity decrease, this is inversely proportional to molar conductivity will increase. So this second statement is also wrong. Henceforth, both the statements are incorrect. Option A is correct. Question number 20, if we go, they have directly given benzene along with Br2 and Fe. So as soon as you give Br2 and Fe into the reaction, you are going to get benzene with Br. Now, as soon as you give Mg dry ether in presence of D2O, what you are going to get? You are going to get bromine replaced by deuterium, and here will be D. Next question, question number 21. The final answer will be deuterated benzene. Next question number 21. Solubility of AgCl will be maximum in which one of the following? I hope you understand AgCl will have common ion effect. Will have what? Common ion effect with KCl because there is Cl, with HCl because there is Cl. and with AgNO3 because there is silver. Now, as they are having common ion effect, it won't get included with them, whereas it will show maximum solubility with whom it will show maximum solubility with deionized water. It will show maximum solubility with deionized water. Question number 22. If we go for question number 22, they're asking that which one of the following arrangement represents correct order of least negative to most negative electron in enthalpy. Okay, so I think we all understand the one who will gain the most number of electron or be very happy, that is nothing but fluorine. So among the given, after fluorine, who will come? Oxygen will come, then carbon, because along the period electron negativity decreases. Increases. So fluorine have the maximum, then oxygen, then carbon, but down the group it decreases. So after carbon, there is aluminum, and finally it will be calcium. So this will be my order of electron gain enthalpy, or EGE. Coming for question number 23, students, if question number 23, you see which is the strongest acid they have asked, the one who will have the best stable conjugate base will be the strongest acid. If you see, O minus will be highly stable throughout the ring due to the minus M effect and minus I effect of NO2. So henceforth, this one will be the strongest acid. Question number 24. If you go for question number 24, they have given a series of reaction, that is phenol. They have given along with phenol, what will happen if you give NaOH, that is it will be phenoxide formed. So it will be O minus formed. As soon as you give O minus and CO2, it will form what? It will make sure that it is putting it, the whole thing into the ring. O minus will come here and this will go for attacking. So it will be O minus. In presence of that, it will become C double bonded O minus. As soon as you give H3O plus, I'm doing in short, you are going to get what? You are going to get OH, COOH. This is called as nothing but salicylic acid. Next question. We go for question number 25, students. Question number 25, they are saying that this much percentages they have given. So after they have given the percentages, they have asked for which one is going to form how much. So I think we have all solved it in chapter number 1. So for 100 gram of compound, you need to make that number of moles. So there should be hydrogen, there should be carbon, and there should be nitrogen. So each of them will be having different values. For example, when we talk of number of moles, hydrogen will have 8.7 by 1 to 8.7. Whereas next one, carbon will have 74 by 12, so it will be 6.77. And finally, my nitrogen will have 1.24. So this will be the number of moles. After we got the number of moles, we are going to have, after we got the number of moles, we are going to have the ratio. The ratio will be what? The ratio will be taking in with respect to the least one. So 1.24 being the least one, everyone will be divided with respect to 1.24. So 8.7 divided by 1.24 gives me 7. Then 6.17 divided by 1.24 gives me 5. And 1.24 gives me 1. So guys, after you got the ratio part, you need to understand that after the ratio, we need to go for the empirical formula. So what will be the empirical formula? So by the way, before going for that, how I found these values, let me explain. I am getting 7, that is 8.7 divided by 1.24. Here how I am getting, here I am getting 6.7 divided by 1.24. This is how we are getting the 1.24 divided by 1.24. Now what we know, empirical formula is nothing but H7C5H7N. Now, what is the mass? Here, the mass, if you calculate, you will get 81. Now, given molecular mass is how much? Molecular mass is 162. So, 162 divided by 81, you are going to get 2. Therefore, what will be the formula? C10H14N2. This is going to be my final formula, C10H14N2. Now, next question. Question number 26. Question number 26 is speaking about the reaction, guys, there is no reaction possible because neither of the benzene oxide ion can react, nor it can react with fluorobenzene. So as they are not able to react, so it will be no reaction because the reactivity unit doesn't match. Next, buffer. I hope all of you know this. What is buffer? Buffer is a solution which neither changes pH on addition of acid or addition of base up to certain limit. So in case of 27, which one will be forming a buffer where the equal mole ratio is there? That is NaOH plus CH3COH in 1:1 ratio where they form what? They form buffer. They form buffer. Next question, which one will be distinguished by Felling's test? I hope all of you know benzaldehyde and acetone can easily be distinguished because acetone will be giving me the differentiation test with Felling, and hence both acetone and benzaldehyde are the ones who can be differentiated by what? Who can be differentiated by Felling's test. Next, 29, if we go, in case of 29, what we will see, we'll see that they're asking ratio of electron to bond pair and on ozone molecule. So I hope everyone knows this is my ozone molecule, and in my ozone molecule, when we calculate the number of lone pairs, we do find that total 6 lone pair is there, and how many bond pair is there, and the number of bond pair in this case is only 3. So the ratio is 6:3. That is nothing but 2:1 is the ratio of lone pair and bond pair. Question number question number 30. When we talk about question number 30, we do find that they're asking us about a reaction where delta U, delta S are being given and delta G is being asked. Guys, if you see this reaction, you will find that the delta U is 2.1 kilocalorie and delta S is 20 kilocalorie. And what temperature they have given? They have given 25 degrees C. In the sense of 25 degrees C, if we multiply the temperature or add the temperature with 273, we are going to get how much? We are going to get 25 plus 273, 298 Kelvin. So what will be my delta G formula? My delta G will be delta H minus T delta S. Delta H is nothing but 2.1 kilocalories. So it will be 2100 minus, it will be 398 multiplied by 20. If you do this, what you are going to get? You are going to get delta G to be minus 2.67 kilocalorie. This is going to be my value. And I hope this is clear to all of you. Next one, we are going to discuss about the good question, that is hydrogen atoms in a complex is formed by nickel. Now, what they are saying is, first of all, one thing we have to do, that is last question in this one delta H minus D delta S. I just forgot to say that, mention you how we are going to get delta H. First of all, we need to calculate the delta H. How to calculate the delta H? In this case, delta H, we have to be calculated by delta NG RT. So R value they have given 2, T value, 398, and delta ng. Delta ng you have to calculate by the reaction. So it is 2. So as soon as you multiply this 2 into 2 into 398, you have to put it here. So it will be 2 into 2 into 398. As soon as you put, you will be getting now the delta ng is product minus reactant. So delta ng will be product side. Product side is having gas. So gas molecules of 2xO2 is forming. So delta ng will be nothing but 2. That's where we are getting 2, and then whole after this delta H you put, and after you do the calculation, over here, then you are going to get the final answer to be how much? Then you are going to get the final answer to be minus 2.67. Yeah. So if you don't calculate this, you won't be getting the right answer. Anyways, coming for the next, guys. here delta NG minus, wait, we will do it freshly again. I'm getting tangled over here. It becoming very nasty. So we'll be doing from the beginning. Sure. I will tell delta H from the beginning. So students, what is delta H? Delta H equals to delta H minus delta equals to del NG RT. So it will be delta H equals to del NG RT minus delta U. So after you put the value, you are going to get delta H. After you get delta H from here, then you have to put delta G. Delta G will be equal to delta H minus T delta S. T and delta S values are already being given. After you put all the values, then you are going to get the final answer of how much? Then you are going to get the final answer of minus 2.67. Yeah, that is the way. So if you don't calculate this formula, which I didn't show you at the first time, you won't get delta H. Delta U they have given, they have not given delta H. Just now, I was skipping it. Anyways, number 31. As soon as you put 31 question, you see that they have given a nice one, that is nickel to iron and dimethyl glyoxide. This is a very, very important or very nice thing to understand. They have asked hydrogen atoms. They have not asked hydrogen bonds. So please don't get confused with it. So first of all, you need to know the complex. What is the complex? Nickel dimethyl glyoxide DMG complex is defined as C4H7N2O2 whole 2. In this case, how many hydrogen atom is there in one? In one, there are 7 hydrogen atom. Total, how many? 2. So 7 into 2, it will be 14 hydrogen atoms for the whole complex. How many atoms are there? 14 hydrogen atoms for the whole complex. Next one, we do see that question number 32. In the question number 32, the rate law of decomposition of a reaction is being given. I hope all of you do know this is a zero order reaction, and for zero order reaction, for the because specifically hydrogen iodide, do not get confused that it is to second order. So in case of zero order reaction, what is the unit? The unit is liter per mole per second. So this is the answer of the rate constant K. Next, question number 33. In case of question number 33, they are simply asking who will be giving iodoform reaction. We all know the one who will be having methyl in the alpha position, they will get iodoform. So if we talk of acetone, acetone will get iodoform reaction because it has alpha position methyl. As it has alpha position methyl, it will give us the reaction of what? It will give us the reaction of alloform. Next, question number 35. Sorry, 34, we left one. 34, if you see, they are giving us the Kc value and they are asking us the overall value of Kp. So we need to go for the Kp calculation. First of all, let us not skip direct. Let us go one by one. So our value is 0.082 multiplied by 1000. They have kept as temperature. It will be 82 atm liter per mole. Now next one, delta Ng, you have to calculate for A gas in equilibrium with B gas and C gas. If you do this, you are going to get how much? Delta Ng will be equals to 1. Now next one, if you go, you will find that Kc is multiplied by RT to the power delta Ng is equals to, will be 10 into 82. That will be giving me 820 as my Kp, because Kp is equals to Kc RT to the power delta Ng. If you do it, you are going to get 820 as my answer. Next, question number 35. Question number 35 says that which can't be giving benzaldehyde. Definitely option number 3, because if you see, it is benzoic acid. And they are giving you what reaction? They are giving you reduction. Reduction reaction. ZnHg and concentrated HCl is a reduction reaction which is designed for aldehyde and ketone. Clemenson reduction reaction is designed for aldehyde and ketone, not for benzoic acid. So even if you give zinc and Hg in presence of concentrated HCl, it won't work. So it will be no reaction. Next, question number 35 done. After question number 35, question number 36 speaks about the series of reaction. First one is SNI, CH3, CH2, COOH. As soon as I give SOCl2, what I will be getting CH3, CH2, C double bonded OCl. Now from here, we will be giving you NH3. As soon as we give NH3, it will be CH3, CH2, C double bonded O, NH2. Now from here, as soon as we give KOH, PR2, what will be my final? I hope of you do realize it is Hoffman degradation. As soon as it happens, the degradation will occur. It will be CH3, CH2, NH2. This is going to be my final product, CH3, CH2, NH2. Now, question number 36 finish. Now we are going for question number 37. So for question number 37, they are asking which one is for radial node. This is very easy. This is just pure NCERT memorized portion. So if I take a radius and wave function over here, so when one normally it will be looking like this. That is, if one part is there, this is going to be my one radial node. So option 2. It's very easy. Now next 38, 30 is also very simple question. They are asking us what will be the delta U. We know delta U equals to, what is delta U? Do we need to put the formula? No, we need not to put the formula, because we very well know that delta U is directly dependent on change in temperature. So as it is directly when changing temperature, and changing temperature will be zero in isothermal. So therefore, what will be the delta U? Therefore, delta U will be also equals to zero. So answer will be option number 1. No need to put the formula. Answer will be option 1. Next question, if we go, where to find that, they're asking us about energy of the second orbital hydrogen atom. Okay, no, I skipped one question, 39. 39 is they're asking that structural feature of protein is they have what type of linkage? Protein has what type of linkage? Protein possesses simple peptide linkage. Next, question number 40. In case of question number 40, what we observe, we see that they are asking us about the energy of the second orbit of hydrogen atom. How we need to do? We know that En is equals to minus of z square multiplied by 13.6 divided by n square. Now guys, we need to convert 13.6 into joule. So it will be 13.6 into 1.6 into 10 to the power minus 19. That will be giving me electron volt. That will be giving me 2.176 into 10 to the power minus 18 joule. This will be the scenario. Now, what will be my energy of the first state? It will be minus of 3 whole square multiplied by 2.176 into 10 to the power minus 18 divided by how much? Divided by 1 square, because you are finding for 1. It will be giving me minus 1.9 into 10 to the power minus 17 joule. Which of the following alpha amino acid is not optically active? Definitely glycine is not optically active. 42. Oxidation state of nitrogen, NO, NO2, NO3 minus, and NO. Okay, so first one will be NO3 minus, because it has +5 oxidation state. It is greater than NO2, which has +4 oxidation state. It is greater than NO, which has +2 oxidation state. It is greater than N2, which has +1 oxidation state. 43. Guys, they have given us 3A plus 2B in equilibrium with C. This will be coming as C of A cube, and it will be B square according to the formula, as we know, equilibrium, equilibrium. Next, guys, they are asking us about the one who will give the best electrophilic substitution. We know better will be the electron donation, better will be the ESR or electrophilic substitution. For that reason, who will be giving the best electrophilic substitution? It will be the benzene ring with C2H5, the one who donates electron very well. This will be donating electron very nicely, and henceforth this will be called as what? This will be giving us best ESR among all that has been given. Last one, they're asking the values of spontaneous and endothermic. 45, to become spontaneous, we need del G to be negative. Now endothermic means del H is positive. The one who have del H is positive is definitely 48 plus 48 kilojoule. If I want to make the whole thing to be negative, I need to have a big value. So my delta S also should be positive. So that is plus 135 kilojoule. So overall, as we know, the formula is delta H minus T delta S. So overall, if we multiply, we can get negative value. So henceforth, option will be option number 3, that is plus 48 kilojoule plus 135 joule per Kelvin. I hope all the questions have been cleared. In the doubt, thank you for your time and all the best for your exam.